Good morning. In this lecture video, I'm going to explain uh, the IC regulator, that means 78XX series voltage regulators. So, first we'll see functional block diagram. 78XX series voltage regulator consisting of a POS transistor. To this transistor, we apply input voltage and we take output voltage. Okay. And here it consists of two resistors which acts as a voltage divider and one amplifier. Okay, it has a inverting input terminal and non-inverting input terminal. So inverting input terminal is driven by the voltage divider, and to the non-inverting input voltage, this non-inverting input, we give one reference voltage. Its output is given to the thermal and schedule current limiting, and then its output is given to bus transistors. This is the functional block diagram of three terminal IC regulator. That means, so this is the practical IC. It has a three pin, 1, 2, 3. Pin number 1 is input, 2 is ground, and 3 is output. 7805 means here XX can be 0506 based on the output voltage required. So this is the practical one simple board. So this is an adapter. Through this we connect unregulated output voltage and you will get a regulated output. This is a regulator and this one is heat sink. Heat sink. So we'll see. So it is a typical three terminal voltage regulator. Here XX can be equal to 05, 06, 08, 10 up to 20. Okay. If it is 07805 produces an output of plus 5 volt. If it is 67806 produces 6 voltage. 808 means produces plus 8 volt and so on up to 24. 7824 produces an output of 24 volt plus 24 volt. So as we have a built-in reference voltage, V reference drives the non-inverting input terminal of an amplifier. This one. And then voltage divider. So this is the voltage divider consisting of the resistors R1 and R2. It samples the output voltage and then return as a given feedback to voltage to inverting input of an high gain amplifier. This is an amplifier. And here output voltage is given by Vout is equal to V1 R1 plus R2 divided by R1 into V reference. So resistors R1 and R2 are inside the IC itself. That means they are decided by the factories. I mean at the time of manufacturer. So we get a different output based on the different values. So minimum 5 volt to 15 volt in the 78XX series. So the tolerance of the output voltage is plus or minus 4%. 4%. That means if we require 5 volt, there may be a chances of getting 5.004 or 4.96. That is called output tolerance. And POS transistor, this one can handle a 1 ohm load current provided that adequate heat sink is used. That means this is the heat sink. So this one is heat sink. To this we attached 78 series regulator. And the thermal shutdown and current limiting. So chip will automatically shut down when the internal temperature becomes too high, that is around 175 degrees Celsius. And that means it is a precaution against excessive power dissipation. It depends upon ambient temperature of the heat sink and other variables. So because of thermal shutdown and current limiting device, 78XX series are almost indestructible, and so it cannot be destroyed. So now we'll see how do we use this as a regulator. So we consider 7805 fixed voltage regulator. This is the simple circuit diagram. This is the voltage regulator. So this is one input Vin is applied to pin number 1 and we take output from pin number 2 and 3 is the ground. So figure shows 7805 connected as a fixed voltage regulator. Pin number 1 is input, 2 is output, and 3 is connected to ground. Output voltage is plus 5 volt, and maximum load current is 1 amp. And typical load regulation is 10 millivolt for load current between 5 milliamp to 1.5 amps, and typical line regulation is uh, 3 millivolt for an input voltage of 7 to 25 volt, and ripple rejection is 80 decibel, which means it will reduce the input ripple by a factor of 10,000. So with an output resistance approximately 0.01 ohm, 7805 is a very stiff voltage source to all the loads within its current rating. So now let's see this circuit diagram. We use additional capacitor. See C1, and at the output side one more C2. So the resistance are called. It is to prevent the oscillations. That means inductance of connecting wires between the filters and IC may produce an oscillations inside the IC. So to avoid that oscillations, we use capacitors. So manufacturers recommends to use bypass capacitor. We call bypass capacitor C1 on pin number 1. And to improve the transient response of the regulated output voltage, uh, bypass capacitor C2 is used in pin 2. So the typical values of capacitor is 0.1 microfarad to 1 microfarad, and these values are given in the datasheets of 78XX series. That is, it suggests 0.22 microfarad for input capacitor and 0.1 microfarad for output capacitor. Okay. So regulated in XX series has a dropout voltage of 2 to 3 volt depending on the output voltage. That means there is a drop down voltage across the within the 78XX series. The drop down voltage is 2 to 3 volt depending on the output voltage required. That means to say the input voltage must be at least 2 to 3 volt greater than the output voltage. That means if you want output voltage of 5 volt, input supposed to be at least 7 to 8 volt. Otherwise chip stops regulating. So there is a limit of maximum input voltage because of excessive power dissipation. For example, for 7805 will regulate an input voltage approximately 8 to 20 volt. Minimum is 8 volt and maximum is 20 volt. If it is greater than this, so there is excessive power, there may be chances of destroying the device. So again, datasheet gives the minimum and maximum input voltages. So this is about 7805 a regulator. Now we see photodiode. Again, it is a special diode. Photo means it is a light. It depends on a light. So when the light falls on it, it acts. It becomes forward bias. So this is the symbol of photodiode. Again, it is a semiconductor diode. When exposed to a light, generates a potential difference or the changes its electrical resistance, then allows the current to flow. Again, we call it as a light detector, and it is used to convert light into current or voltage based on the mode of operation. That means it converts light into voltage or current. So it consists of optical filters, built-in lenses, and also surface area. So diodes have slow response time. So this is the practical diodes. So this is called as a lens or windows. What is a lens or windows? This one. This is the different practical photodiodes. So again, similar to regular semiconductor diode, except they either exposed to or packaged with the window or optical fiber to allow light to reach. As I said, this is the window. Again, uses PIN junction. So PIN means P-type and intrinsic semiconductor and N-type semiconductor rather than PN junction to increase the speed of response. That means undoped intrinsic semiconductor region is used between P-type semiconductor and N-type semiconductor. These are the layers of PIN diode. P-type semiconductor I intrinsic semiconductor and N type semiconductor. These are the layers of PIN diode. Okay? And it is designed to operate in reverse bias. That means photo current flows in reverse direction, as in Zener diode used in reverse bias. Okay, so under forward bias, conventional current flow will flow from anode to cathode following the symbol. I mean, this is the symbol. And photodiodes are classified based on its construction and functions, as one is PN photodiode. So it uses uh, P-type and N-type junction. Schottky diode. So this is the a simple PN photodiode, and this is a Schottky diode. And PIN diode. This is a PIN diode, and Avalanche photodiode, and this is a Avalanche photodiode. So the application, it is widely used in where the detection of light, color, or position is uh, required. The main features are linearity of the diode is good with respect to incident light, noise is low, response is wide spectral, rugged mechanically, lightweight and compact. So long life. So as we know here, input is a light. Input is a light. So we'll see some light definitions and the corresponding units. So as per the quantum theory, light is a form of photons, and each photon delivers an energy packet to the surface which falls on it. So that is expressed as W is equal to H of joules. H is a Planck constant, that is 6.624 into 10 to the power minus 3 joules second, and F is the frequency of light waves in hertz. That means light also behaves as a traveling waves. So and its frequency is directly related to wavelength. Wavelength in the sense the distance between successive peaks. So F is equal to V divided by lambda, where V is voltage of light and lambda is wavelength in meters. That means this is called wavelength. So the distance between the successive peaks. The crust means maximum voltage and throw means minimum. And units of wavelength is angstrom or micrometer. That means 1 angstrom is equal to 10 to the power minus 10 meter, or 1 micrometer is equal to 10 to the power minus 6 meter. So again, intensity of light is measured in units of luminous flux incident on the unit area. So units of luminous flux are lumens. 1 lumen is equal to 1.496 into 10 to the power minus 10 watt. And practically, the unit of light intensity is 1 lumen per feet square, called foot candle. So 1 foot candle is equal to 1.609 into 10 to the power minus 9 watt per meter square. So these are the light definition and the corresponding units. Since so photodiode input is light. Now we'll see operation of photodiode. Okay, again it is a PN junction diode. I mean, I say it can be a silicon or germanium. Operation the reverse bias region. So this is the simple circuit. See, this is the PN junction. I mean photodiode, PN photodiode. Here N is connected to positive, P is connected to a negative. So it becomes a reverse biased. Reverse biased. Okay. So reverse saturation current is I lambda. It is expressed in microamps, is limited by availability of the thermally generated minority charge field. That means here this is a focusing lens. To this focusing lens we apply the light. So light is this one. Light is made to fall on the junction. So light photon impact energy to valence electron, causing more electron hole pairs to be released. So valence electrons means electrons in the outer shell. Hence concentration of minority carriers increases, and so does the current forms, that is I lambda. And this is the simple symbol. So Remember, observe that symbol. I lambda flows in the reverse direction. Reverse direction. So valence electrons are the electrons in the outermost shell or energy level of an atom. So this is called. So these are the valence electrons. These are the valence electrons in the outermost shell. So as we know, avalanche effect in Zener diode. When a reverse voltage increases, velocity of minority charge carrier increases. So when the velocity increases, there may be chances of collision of minority charge carriers, and hence more number of minority charge carriers are generated. So collision results break into covalent bond, and the electron get accelerated due to high reverse voltage, and they again collide with the another atoms to generate a more minority charge carriers. This process is called as carrier multiplication, and the effect is called as avalanche effect. So finally, large number of carriers moves across the PN junction, breaks the PN junction. The effect is called as avalanche effect, and the voltage at which breakdown occurs is called as reverse breakdown voltage. This is how current forms in the reverse direction, as in Zener diode. It happens in Zener diode. Similarly, to get the electrons from the valence from the outer shell, that is valence band, we use photo energy in the photodiode. Okay. Let's see the VI characteristics of photodiode. So this is the VI characteristics drawn as as a plot of reverse voltage V lambda versus reverse current I lambda in microamps. So a dark current, I mean this is the region, this is the region. Okay. Characteristics corresponding to no light in pigment, I mean no light falls on the lens. And by examining the characteristics, you can see at certain value, that is lambda is equal to 20 watt. I mean yeah, I lambda increases almost linearly with the F semi foot candle, that is the unit of intensity of the light. Okay. So this is about photodiode operation. We'll continue in the next video.